Well, if you're watching this, you're probably aware that this is my wooden scroll saw that's driven by a drill. And if you've seen any of the assembly videos that I put together a year ago, you'll probably recognize that the drivetrain is different. And the reason it's different is I've been chatting with some engineers over the internet, and we've come up with a change in the mechanism, camera mechanism, to hold these down that actually decreases the amount of vibration quite nicely. However, in this configuration that I've got it now, it used to work very nicely, but through a poor choice of materials, it is now working itself loose again. That used to be a very tight joint, but because this is aluminum, it has pounded the hole into such a condition that it is elongated, and it is now putting vibration back in. And the skateboard bearings that I use are built for 18mm rods, and in fact the bolts that are being used as axles are about 1mm smaller than that. So this is all going to come apart. This is going to be replaced with iron, and I'm going to shim up the center portion of the bearings and take the remaining vibration out. This used to be round. I've actually had this new drivetrain in place for quite some time, number of months, but I did keep the old drivetrain, and just for the sake of what the difference is, this is primarily the piece that I was trying to get rid of, and that's where this design came in. However, during the whole thought process, I decided that I was going to cut down on the throw of the piece. This old one had a total throw of about 2.5 inches, which meant from that axle point to that axle point was 1.25 inches. And what's happening here is this has gone to a 1.5 inch throw, which from that point to that point is 3/4 of an inch. So this segment is confession time, and the reason that I'm going to do that is I'm going to confess that I'm a woodworker, but I am not a metal worker, and I exceeded my boundaries on this project. I thought that it would be a great idea to take a very old saw blade from a table saw blade and make the cam out of it, because it was only 72 thousandths thick and it was really tough. So I cut one out of a saw blade and I put it on my drill press, and by George, it didn't even make a dent when I put the drill bit on it. So I got on the internet and I found out that high-speed steel, which is what the saw blade is made out of, is Rockwell hardness 64, and I don't think have any drill bits in the house that would even approach being able to cut a hole in that. And I need a couple holes in the cam, and one of them's a 1/2 inch. And I'll be damned if I'm going to spend $75 on a carbide drill bit, a 1/2 inch drill bit, to cut a hole in it. So, change of plans. In fact, there's the piece of high-speed steel right there, which weighs 34 grams, by the way. And here's a piece of mild steel right here that's going to take its place. Same size, but it weighs 49 grams. And I really wanted to save weight here. This is not nearly as tough, but it's probably just as good in this application, not to deform the way the aluminum did. But I wanted to save weight, so now I'm going to have to counterweight it, which I had planned on doing anyway. And there's my confession. The rest of this is going to be using mild steel. So I'm going to drill a 1/2 inch hole in this piece of mild steel in 2 stages. And this is going to be the axle connecting point, which is exactly a 1/2 inch. So I'm looking to spread out whatever force is being applied a little farther than the previous was. It was only 5/16. Okay, the bearing portion of this crankshaft is made out of 3/4 inch plywood, 18mm plywood. And the way I've done this, I've run a 7/8 inch hole through the bottom portion so that I can actually have 2 skateboard bearings sitting in there instead of just one. Okay, what I've done here is the epoxy is set up, and because this is a piece of plywood and the plies will come apart on a pretty small piece like this, I've set a couple of number 6 screws that I drilled and set through. They're 3/4 inch by number 6 mechanically to hold this in place, and mechanically to make sure that this doesn't come apart. In the previous cam or drive shaft, I actually had it break, and I had to put some bolts together. So that just ensures that it's not going to go bad on you. And the other thing that I wanted to point out, that I'm going to put new bearings in there. This is a 7/8 inch through hole, and these bearings are just a little bit too small for that. So I put a shim of masking tape on there. So I've decided, in the interest of trying to complete this as successfully as possible, to take the vibration out, that in fact what I'm going to do, this is the transfer mechanism. The push rod, actually the crankshaft, attaches onto this bolt here, and this is the drive. Now I've just weighed up the crankshaft and its hardware, and it's somewhere around 105 grams. So what I decided to do was, I've cut 3 pieces of the soft steel, and they're weighing in at about 95 grams. And so I'm going to embed those like that on the side of the basically a flywheel, I guess, the transfer agent, and exactly the same fashion that I embedded the push rod, the crankshaft, into its bearing mount. And the next thing I need to do is enlarge my axle hole, pull-down hole here, to a 1/2 inch. That's where that stainless steel sleeve is going to go in, and then the bolt is, the drive shaft is going to be through the middle and held in place by that 1/2 inch sleeve. So here it is. It's all set up, and I must admit that this is pretty heavy now compared to what it was before, but I'm really looking forward to it being really in balance. Oh, that's pretty sweet. I don't mind telling you, that's such a dramatic improvement. Well, there it is. Service Pack 1 for the wooden scroll saw. And it is seriously an improvement on it. So I will have some drawings right after I get off here that you can make screen captures of and incorporate them into your new design if you so wish. And good luck to you. I'm Tom Stevens. Come on back. I'll have something again sometime.